The northern coast of Chile follows a rugged, but mostly straight line. However, there is one feature that you probably immediately noticed, which breaks this trend. This is an anvil-shaped peninsula, which juts out around 15 miles from where you'd expect the coastline to be. This feature is named the Mejillones Peninsula, and it has a very interesting geologic history. So in today's video, let's cover how this peninsula formed. The first step in the creation of the Mejillones Peninsula is the formation of the bedrock. The oldest rocks of the Mejillones Peninsula are metamorphic rocks known as the Mejillones Metamorphic Complex. However, these are found in just a few small outcroppings. Instead, another formation known as the La Negra Formation is the main bedrock in this area. This La Negra Formation formed around 180 million years ago. This is a time when Pangaea had just begun breaking apart. This caused South America, which was part of the larger continent of Gondwana at the time, to collide with the Phoenix tectonic plate. The Phoenix plate was one of the primary oceanic plates which formed the Panthalassic Ocean during this period. And around 187 million years ago, it began to subduct underneath South America. This subduction would create a volcanic arc within South America. Specifically, it would create a volcanic arc known as the La Negra Arc. And these are the volcanoes that the La Negra Formation originates from. Here is a map of the Mejillones area, and both the blue and the pink on this map are rocks which formed in this La Negra Arc. The gray area here is the older metamorphic outcrops that I mentioned before. But that is the first step of creating this Mejillones Peninsula, the formation of the bedrock. However, this was just the beginning of the subduction within this region. The subduction is a process that still continues to this day. The Phoenix plate continued to drift southwards, and eventually the subduction of this plate would stop in the northern Chile region. However, after the Phoenix plate, the Farallon plate would then begin subducting within this area, building up the Andes Mountains into what they are today. This is known as the Andean orogeny. This formed the mountains at the base of the Mejillones Peninsula today, which is known as the Coastal Cordillera, or the Chilean Coastal Range. In fact, this process of building the Andes Mountains still continues today, although it is not attributed to the Farallon plate anymore, because it has been almost completely subducted underneath the North and South American plate. Instead, the Nazca plate is the plate which is continuing to build the Andes Mountains. This brings us to the true way our Mejillones Peninsula formed. It formed due to faulting. The faults of Mejillones are actually part of a larger fault system known as the Atacama Fault System, or AFS. These faults formed due to the oblique or angled subduction of the Phoenix plate. And it created a complicated system of strike-slip faults, normal faults, and even reverse faults. But the specific type of faulting that formed Mejillones is normal faulting. Normal faulting, also known as dip-slip faulting, is when one block of crust, known as the hanging wall, dips down in relation to another block of crust, known as the footwall. And these are the kind of faults which are found in the Mejillones Peninsula. Specifically, there are 4 of these normal faults: the Morro Fault, the Mejillones Fault, the Cayeta Herradura Fault, and the Rinconada Fault. This appearance of a hanging wall and footwall is actually very visible today if you look at these faults on satellite. As you can see, here is the Mejillones Fault, and we have this ridge, and then this lower land. Most of these faults are eastward dipping. This means that the hanging wall dipped down to the east, and now there are these sharp ridges facing to the east. The normal faulting on Mejillones has created a pattern of horsts and grabens, more specifically half grabens. Horsts are simply the higher elevation regions, which were the footwalls that didn't move, whereas the half grabens are the regions that tilted and slipped downwards. They are known as half grabens because there's not another normal fault on the other side, so instead of creating a kind of dipped valley, as can be seen here, it instead creates a tilted block of crust, as can be seen here. There are 3 of these horsts on the Mejillones Peninsula, known as the Morro Mejillones, Morro Moreno, and Morro Jorgino, and these are all the mountainous highland areas. The half-grabens are known as pampas, or basically flat plains. And these are the Mejillones and Aeropuerto pampas. So that is how the highlands and the lowlands of the Mejillones Peninsula formed. However, when it formed, it was actually below the water. This caused them to be filled with marine sediment, which built up several different layers. Here are some diagrams of the elevation of Mejillones, and as you can see, we have the half-graben, which got filled with marine sediment, and today forms sedimentary rock. This has made it so there is less of a tilt within the half-graben, and it is more of a flat plain. The half-grabens would remain underwater until fairly recently. Around 3.8 million years ago, this entire region began to compress instead of extend, and cause the area to uplift. Finally, 400,000 years ago, the entirety of the Mejillones Peninsula would uplift above the water level. So this is how the Mejillones Peninsula has formed. It started with the formation of the bedrock as a volcanic arc. Then, the Atacama Fault Zone was created, which formed several different normal faults within this area. These normal faults created some areas to uplift as highlands, and others to sink as the half-grabens. Finally, the entire area was uplifted 3.8 million years ago, and eventually went above sea level to what it is today. One more force that has helped shape this peninsula is erosion. Today, there are many sharp cliffs on Mejillones that were formed from the constant wave action. But I am not done talking about Mejillones. The formation is not the only interesting thing about this peninsula. So let's talk about the modern-day geography. As I mentioned previously, the peninsula has 3 areas of highlands. The highest point, which stands at 1,148 meters above sea level, is at the Morro Moreno mountain in the south. And this area is actually protected by a national park known as Morro Moreno National Park. This national park has hiking to the top of the mountain, and it even has 195 species of wildlife. Some of them are even native to the peninsula. Mejillones is also part of the Atacama Desert, because it gets only 63 millimeters of rainfall per year. To the north of the peninsula, there is the small city of Mejillones. It has a population of 14,000, and it's known for being a port city. In fact, it makes up around 7.1% of the tonnage of Chile's external trade. And finally, to the south of the peninsula, the city of Antofagasta acts as a major hub. So overall, Mejillones is a beautiful geographic oddity that has both an interesting geologic history and modern history. But thank you all for watching. If you have any video ideas, comment them below. But I will see you guys in the next video.